Okay, so here we are going to study Introduction to Hypothesis, and I'm recording now. So, what is an hypothesis? First of all, in every experiment, okay, researcher has some idea in the mind, and that idea is whether, okay, there will be difference between the measurements, or whether there will be no difference between the measurements, or whether the one measurement will be bigger than the another one, or maybe if it is about a medicine, the experiment has an idea like, okay, I want to try whether this medicine is effective on this patients, so he has to set up some hypothesis, okay, first of all, and hypothesis 0 is the hypothesis where there is no difference, okay. So distribution, if the null hypothesis is true, so we have this distribution here. State the hypothesis and select an alpha level. So the first step in a research study is to state what is the hypothesis. And the first hypothesis that is stated is null hypothesis. It always says that treatment has no effect. Okay, we are going to apply a new treatment, and H0 says it has no effect, no difference. That's what H0 says. It has no difference. According to the null hypothesis, the population mean after treatment is same it was before the treatment. Okay, that is what this hypothesis says, H0. Okay, and we do the measurements here. Okay, and there is another important thing. Okay, we state the hypothesis. H0 is the null hypothesis where there is no difference. But sometimes, unfortunately, on papers, we see that researchers do some mistakes like that. Although there is a difference of the medicine, researcher says that there is no difference. Okay? So type 1 error and type 2 errors happens. So this is the important thing that I want to emphasize now. Now, what is H0? H0 says no difference. I'm going to give you some more examples about this now. Okay, so the real case, when the real case is that, okay, there is no difference, okay, if they reject HO, researcher says, no, that's not true. H0 is not true, okay, they reject it. But the reality is that it's true, okay? So if it is true and the researcher says it's not true, he makes a mistake, okay? And this is called type 1 error. Therefore, it's because of that we have to be careful, okay? We have to not read papers, articles, and believe blind-eyed to what they say, okay? We have to be careful about what is done, what kind of researchment is delivered, and then we have to have some knowledge, and we should analyze whether there is a mistake there or not. Okay, so here, this is an error that we may face on research papers there. That's why that we shouldn't believe them blind-eyed, okay? It's really a very important thing and a very hard thing. Not everyone is a biostatistician, okay? Not everyone can understand it, so we have to be careful on where we get the information. For example, if it is on Facebook, who write it, okay? Did any research about that? everyone is claiming something on Twitter, on LinkedIn, on any social media. But on this social media, if they don't give you the exact article and where it is published, okay, and you have to search the journal where it is published and whether it's a reputable journal, what are the editors, whether you can believe what they are doing, whether they have controlled the article or they just published the article, okay? So there are many cases really. And when it is held, it is important that we have to be aware that the information at hand may be wrong, okay? And these are the reasons of why it may be wrong, because they may be interpreted wrong, okay? The interpretation may be wrong, okay? Maybe that they carried out the research study, okay? They did everything right, but at the end, at the last step, they interpreted wrong, okay? So type 1 error is that whether they find that there is no difference between the treatment, they say that, no, there is a difference. Apply this treatment, and it's no use. Here, this type 2 error is, okay, there is a difference, okay? So maybe that, let us talk about a diet. We have 2 diets, okay? And if you apply diet 1, it will be better for the patient's levels of measurements, let us say blood levels may differ on that. And if you apply diet 2, yes, it will be low, okay? It will even affect the blood measurements. But the researcher, the reality is that there is a difference, okay? So H0 is false. Why H0 is false? Because H0 is no difference. No difference is false. This is the reality. In the reality, there is a difference. Okay, when there is a difference, retain H0. If the researcher, if the person who is interpreting that says there is no difference, you can apply either of them and there is no difference on the patient's health condition, this will be even fatal. This is really important, okay? So that's why that, okay, we may see lots of paper, lots of research, even on books, but we don't have to rely on them blind-eyed. And these are the mistakes that we may see, okay? Any questions on this? Because this is really important. Okay. Yes, okay, so we can apply many tests on this, and we are going to see this next.